Only sunshine day.
Yes, definitely. That's for the presentation vision. It's not so.
It's better to have snow and rain.
Okay, dear colleagues, we are ready to start our uh, common lecture about Industry 4.0 and circular economy and state of our things from Fabio Bonsignorio, Superior School of Sant'Anna, Italy. Please.
Okay, so thank you for the invitation and the kind introduction. Actually, yes, the topic of today will be Industry 4.0, and actually I want to go in, for example, protocol details or communication details, actually because I think we should wait for the book that is coming from an Erasmus project where Alexander is involved. There will be a lot of details. What I wanted to convey you today with this presentation is what can be done and what it can be done, in which ways it can impact the economy and the society. The main thesis here is that the impact can be extremely significant, so, but we will see. The outline of the talk. So first I will give really a flash introduction to the state of robotics now, a kind of flash state of the art of robotics. Then I will talk about Industry 4.0. Some side effects of Industry 4.0, which are on the circular economy, and we will see what I mean, and also construction industry. And then I will close with by showing that not everything is done, so there is still a lot of room for research. And I will try to discuss briefly also what the potential economical and societal impacts of Industry 4.0. So I promised the flash state of the art. So what happened in robotics? Apart from the very distant past, so people has been working automatons, building automatons for thousands of years, literally. But typically they were limited by the fact that they connected a clock, so in modern terms a state machine, to some actuation and sensing. And the problem is that you cannot implement big state machines, so many states and many procedures on a clock-like mechanism. What changed was the introduction of a microprocessor in the 60s. And the very first application, that picture in the corner, the black and white picture, is the very first installation in a factory of a robot. It was a GM factories. And the man behind this was, actually one was Jay Davos and the other was Joseph Engelberger, who is a kind of founding father of robotics. And that was based to three main sources of knowledge: mechanical engineering, because you needed to design the structure; computer science, because you needed to write programs; and control engineering, because you needed to follow the trajectory. The impact was so big that today, if you look at those numbers, so basically today you cannot even think of building a car or a washing machine or a big item without having many robots. So there are still a small percentage of manpower. There are a few percent of manpower. So if you have 100 workers, you have 5 robots in South Korea, where you have many. But for example, in Italy, you have 2, 3, and in other countries, you have 1. But the point is that if today some company wants to build a car manufacturing plant in Vietnam to save on the salaries of the people, they still have to build, to put the assembly, the painting, a number of of part of a plant need to be made by robot for quality reasons. It's like writing by hand or writing by a word processor. So today, the quality that is required by a modern product like a car or a washing machine requires that you use a robot, because otherwise you don't have the needed repeatability, the precision and the accuracy. The second way, which is where we are now, is actually based on IoT technology, machine learning, and some artificial intelligence. So IoT means that you can connect objects. So maybe some of you already know, but you can connect different objects like you connect to the internet. The difference is that now a wireless net interface costs dollars. And this means that in any item which costs 100 euros or $50 or so, you can put a network interface. So it means that in principle, we don't have yet a network interface here, but I could have. And I could also put sensing here. So because what I want to, the main message that I want to convey you is that most of the things related to the Industry 4.0, IoT and machine learning and artificial intelligence have still to happen. So we have the technology, we have the tools, and we need to use them. But while I will also talk about things that are issues that are still scientific challenges, so things that we don't know when will be available. But these things are available and are in most of the cases are not yet used, because it could be nice to have here something which tell me when I'm leaning on this desk, like it would be nice to know if there is someone sitting on this chair. And this would cost 10 more euros on the cost of this chair. So maybe this chair is still on the limit, but any in an armchair or in a sofa, there is no reason not to put a number of sensors. For doing what? Well, many things. No, the limit is imagination. What people expect, so people do analysis about what can happen now that we have this new possibility. Where I repeat, the main possibility are the possibility to connect into a network ordinary things, because the cost of connecting is low and the network management is easy, is done. And the machine learning, meaning you can extract trends from data. For example, now in most of the cases, we needed to program the thermostat of a heating system. You know that the Nest, which is an alphabet, also known as Google company, has built a machine learning based thermostat that you can, so for the first week, you put manually the temperature that you want, and then it learns from your habit and self-program. So this is nothing, but if you can choose between a thermostat that takes reading the manual, that, I don't know, you think to your old aunt house, that she has to call you to program a thermostat, or another thermostat that she can program by herself. It's nothing, but people will prefer the self-programming. So if you are able to propose something like that, people is happy. And so what most analysis expect is a dramatic increase in the turnover of industry working in robotics, in 10% and so. So you know that in Europe and they don't differ so there are several studies, and most of them converge on these 60-something billions in 2025. We have, if you think that the global gross product is 80, 90 trillions of dollars of euro, because they are approximate numbers, you see that we are still talking of a niche. So this is the natural growth of what is already has already been started. So what I mean is that this forecast is probably very conservative. So it's possible that the impact, if you add, and also it depends on the definition of robot, because if a robot has to be an arm, has to be a vision system, but if I talk to a wider context of smart systems, like the thermostat, the self-programming thermostat, then basically you can easily think of transforming all products and all objects. I mean, this is, so I told you that I will stay a bit high level, but something that we tend to forget is why we engineers work, right? So our purpose is to make the life of people easier, right? And so to create, in a sense, we create new resources. So resources are raw materials in nature and people able to work. So if you think about what we can do today with respect, it's a common sense, but with respect to 1 century ago, so we have more, we work less, more or less employing the same resources or maybe less, because a car of a 60 had a weight of 1 ton and something. Even a luxury car now, it doesn't reach 1 ton. So we use less material, we work less hours, and we produce better quality things. And this is something that will be extremely accelerated by this process. Why? Because so I was talking AI. I don't know if I can classify computer vision as AI, but in part it is computer. So the recognition of objects in a scene is a kind of AI, but it's a kind of AI that now works. So what does it mean to be able to connect many things, to recognize objects, and to learn patterns, for example, in quality? So you may have always the same defect in the car, and you don't understand why. In the past, you may need a team of 20 engineers working for years to discover what's happening. Now you can collect automatically all the data. In the past, they had to go and ask for the data and find them written somewhere or on some floppy disk in some old computer. So you can do in a fraction of a time with limited effort this kind of analysis. So does this mean something? Because, I mean, you may say, okay, this is not rocket science. But if you look at how the objects are produced today, because at the end, so we are engineers and not philosophers. No? So our purpose is not to, so I'm not dismissing the importance of philosophy or other things, but what we study is how to build things with less cost, how to build things that before didn't exist, how to solve needs of people. So what is relevant here is that these things that seems not to be so revolutionary, so being able to recognize objects in certain conditions, being able to recognize patterns if I have many data, and being able to connect things at a low cost. These are the 3 things. And these 3 things seem not very, so you may say, well, okay, so it's nice to take the weight of a person sitting on the chair, but I can live without it. Now, because it's still not mandatory. What is, why, the reason why is irrelevant is, so you know that we live in a market economy, or if you want, in a mixed market economy. This means that we decide what has to be produced on the basis that some entity, some company, some enterprise has a profit in producing those objects. The example of the cars. When you produce cars, we have huge plants, maybe more than we need, able to produce cars. And those plants are sometimes used and sometimes not. Those of you who have time to look at the economic pages of a newspaper or magazine, we will see that car manufacturers are very, I give the example of cars because it's the first place where robots were used, and is one of the places that could be completely disrupted by Industry 4.0. Because what they do is that they do enormous profit when they are able to work at full capacity or close to their capacity, or they lose enormous amount of money when they don't sell enough cars. And why this is a problem? Because they have a huge infrastructure to build in a so-called transfer line. So they can produce many, many cars very, very fastly, roughly one equal to the other. And what happens is that people this year want blue cars, sport cars. Next year they want city cars. So if you have a plant for building sport cars and people want city cars, what happens is that people wishing city cars don't get the city car. And you have a lot of money, of idle plants that cost money to you, and you cannot sell your sport car. So this means that what they mean with this, markets are turbulent because people change their ideas very quickly. The economy is very bumpy, so you have booms and busts. And this makes that what you really value is flexibility. So you want a plant which is able to produce at a very low cost. I give you an example of a transfer line of today. Today, from a typical car manufacturing plant, you get one new car every 8 minutes, and it's going down. So it's 8 minutes. But if nobody wants your car, that's a poor loss for you. So changing the mix of products, so what people want, and the quantity. So it's turbulent. It's a kind of turbulence. If you look at so if you think to the vector of products that people want, no? The vector is every car has a number of optionals, and you assign a number to every optional. Then you have the dimension of the engine. So it's a vector. Of those vectors changing time and changing a stochastic way. This, from the point of view of people building production plants, is a real mess. And consider that the strength, the strength of the American model with respect to the Soviet model was that when people was happy with having low cost, very similar items, so all the same shirt, all the same car, being able, like a state-owned system was able, to have very, very big plants and produce many, many items, one equal to the other, was a definite advantage. In fact, in the 50s, in the US, people was extremely worried by the fact that Russian cars were cheaper. So the whole system in Russia was more effective than in the Western world because in America you had big plants, but not as big as in a place where you have a big country deciding we will have one car factory. It will be the biggest. But if people want cars not all equals, or want to dress in different ways, having a bigger plant doesn't help. What helps is having a more flexible plant. And the more flexible plant was possible with robots already in the 70s, 80s when the overcome happened. But it's much easier now because these plants are still similar to those transfer line of the 50s. It's because you can have a different model of the same Skoda, but different, not so different. Different color, maybe 10 different colors, different optional 5, 6, but not a short car and a long car. So you can have what in jargon is called lot 1 customization. So you cannot have an industrial plant which produces at the cost of mass customization. So you can have Armani suites at the price of H&M or Zara. No, this is the idea. So this, what industry 4.0 will in the end make possible will be to have mass customization. So everybody with a different dress, a different car, a different house, but at the cost of mass production. Because what really changed the life of most people was that at some point mass production was possible. And so not only the rich people could enjoy a decent level of life. And this was mainly a technical issue, so it was a consequence of industrialization. This is the very first factory. The very first factory was in the UK, and they think that this was in 1770 something, so it was in the 18th century, so a lot before, for example, than Italy. So Italy industrialized more than almost 2 centuries later. Despite being having I don't know. The problem is, when I will try to go. The problem is this is, for example, the textile industry, which was the first industry by definition. The situation is this one. So when you assemble the cloth, so when you sew the jacket, you need someone with a sewing machine like those that you can see in many homes and working manually. This, you say, oh, so? This is the reason why a lot of the textile industry moved from Spain, Italy, Greece to China, Vietnam. And this means that in China, Vietnam, they started to have a much better quality of life in economical terms, while Italy, Spain have huge areas that went into a crisis, which is still lasting. So this technical, so I understand this can be a bit different from what you listen to usually, but it's important to see, to put things in context. So you have this tool, you can connect things, you can recognize objects, and you can learn patterns. What you can do with this, you can disrupt the industrial system. Because the textile is a sector, for example, cars and clothes. Cars requires a percentage of the cost of a car less than, about the 5% of less, according to the latest data, is the cost of all the people in the factory, including the top, from the top manager to the cleaning person. Less than 5%. In textile, the cost of assembling clothes is more than 30%. So if you tomorrow are able to find a way to sew automatically a jacket, you can have a significant impact on the economy. Because there is this point. No, and so what is really happening now, it's happening in Italy, it's happening in Germany, it's happening, I think, in Russia, it's happening in many places, is that a number of companies are defining very structure, because now the current model of production is you have the brain, so you have marketing and research in a Western country, and it is usually small. Then you have the assembly for big items like washing machine and cars is still, or computers, is still in a rich country. The labor-intensive activities are spread. I think the supply chain of General Motors is has 300 suppliers distributed in more than 100 different countries. So this is the reality of today. So we have this production spread everywhere. And what happened is that you have this dislocation of of labor from a country to another one. What is happening now, and is exciting, is a good opportunity for the old industrialized countries, is that we have these two processes. One is that we can invent new products, like drones, like intelligent thermostat, or even having reusable rockets, because this is a robotics application. You have these rockets that go up and then is driven down. So this requires that you are able to target that cross, and your robo-rocket is able to follow the task. This is a typical application of vision plus control, plus identification and or machine learning, or not deep learning, but machine learning for sure. Drones also requires some intelligence to be driven. But these are new products. And then you have new mobilities, so you can have the possibility of having not the taxi without taxi driver. And you can also have an impact on agriculture and also on the military. So this is one of the most successful robots on the planet, because it's routinely used to fight against the North Pakistan insurgent, for example. So this is an important one. So really, you needed. Now I will give you some example, but really it's up to you, up to us to find what to do with this thing in terms of functions of what you have. For example, a toilet could make the analysis of your this could be very useful, for example, in an hospital or for elder people, because you may have or this is not connected to my doctor, but it would be very useful. So now I am comparatively young, but still comparatively. But it would be nice to have not an ACZ once every 2 years when I have time to go to a clinic, or having it online, because maybe I could see an heart attack in advance and avoid problems to me and cost to the community. So this is what, at the European level, people don't use the word Industry 4.0, which is used in Germany and in Italy, but use the word digitalization of the European industry. So it's a kind of joke, because this is, that's Europe, no? So if a word is being adopted in a country, you need another one not to look partisan. But it's very clear, because what you can digitalize are the products, the services, and this is to a large extent is almost done, because you can buy many kind of services. But for example, if you call a call center, you will have a person, a low-pay person that is answering on the phone. In many cases, you may have an AI answering to you. And the digitalization of processes, which means making flexible. So in some sense, it's going back to fragment. So before industry, you didn't have, for example, industrial products that shows all similar one to the other. You hadn't the problem of, I'm too fat for this shirt, because people was doing shirts one by one. And so you hadn't the problem, my body type is not okay. No, everybody. The fact of feeling too thin or too fat is a typical consequence of mass industrialization, because of course you cannot tailor-made what you drive, and this is the change. So now we can go back to the flexibility of craft, of artisanry, craftsmanship, at the cost of mass production. So it's really and who will be able to do that first will be richer than the others, in terms of countries, in terms of people, in terms of companies. And this is, in Germany, they are not, so they are smart. And actually, they have started this, for example, this Arena 2036 initiative, that it is really an incubator for automotive startups. And this is something that sounds like it's really transgressive, no? Because the car industry is like oil industry, or steel industry, it's super conservative, super. And the idea is that what could be disrupted is really car industry, because tomorrow I can give you the car that you want, with the batteries pack that you want, and I can give you in 2 days close to your home. So you choose on the internet or in a shop, you see rendering in virtual reality or augmented reality of a car that you want. We discuss together, we change, and tomorrow they will take you, or it will come to you by itself. No? So this is something that seems science fiction, but it's an application of self-driving cars. So why I should go to the shop to buy the car and not receiving the car at home? For example, Tesla already does that, but Tesla is a niche. So it's a very expensive luxury car, and they take home to you with a drive, so it's not coming by itself. But so the idea is that you understand also. Again, I wanted you to pay attention to these things, because usually you miss these aspects. So it's very interesting that Germany invests in electric engine and new car technologies, because they know that the wealth of Germany is largely based on many things, but mainly on car industry. So high-level car manufacturing is what makes Germany a comparatively rich country. And they know that this can change. And so they don't wait to discover that the companies are out of business. They proactively, so they try to anticipate, and they want to do the revolution. Because if you wait for others to eat your cake, it's better to be you who change that. And they are exactly doing that. This is in Italian because this is the Industry 4.0 strategy, which was implemented by the Italian government already a few years ago, and it is an ongoing program. And you see what it's in Italian, but from the picture you should understand, but I will explain you. So the point is that self-driving car or partially self-driving is also self-driving trucks. So the logistics, so the way you connect things from a unit of production or to a consumer interface, a shop or a shopping mall, can change. And then you have I will give you an example of this in a minute if I am. 3D printing. 3D printing means that I can personalize things. So you don't need to have a plant. So a 3D printer is a kind of small manufacturing plant. For example, already in aviation, many times they don't have warehouse of components of helicopters. They just 3D print them when needed. But helicopters are very expensive and the components are very expensive. You can afford a high-end 3D printer. It's better than sending from the US or from Asia the component. Then nanotechnology. So nanotechnology means that you know the gecko story. The gecko is able to climb a wall with no adhesive. It's a nanostructure of the foot of a gecko. So nanotechnology means that you may have a kind of Velcro which is much better than what we have now. So this is a solution to climbing robots, because if I have this kind of tips, I don't need a very particular structure here. While now it's a bit annoying to find a way to adhere to the wall. But also robotics, yeah, but they already have robots. What do they want now? Well, they have robots for doing something. They don't have robots to pick things from a basket and put in another place and move in another place. This is something new. And then, of course, autonomous vehicle. And big data means the relevance of big data in this area is that you can optimize the flows and intercept defects before that things go out of a factory. So what you need to think about is a super competitive environment where there are a lot of so many companies, countries, people are actually fighting for survival. And all these people, companies, countries, have very good instruments and very high level of knowledge. So, you know, you may feel, sometimes I feel intelligent. No? Okay, there are hundreds of millions of intelligent people. So being intelligent is not enough. Being well prepared is not enough. What you need to understand is what's going on and have a creative attitude. This is a bit strange. Also, traditionally, people was, in particular in engineering school, was taught to study, shut up, and study. Then one day you will be able to say something. And now it's the opposite. Now it's think creativity. So what you can do with this? So it's quite. So this I think is a welcome change, no? Because in this context, being creative and thinking laterally is an advantage. In a factory of the 50s, was not an advantage, but because you had to screw your finger, or if you were in engineer, to do your drawings, and no comment, because the drawings are like last year, like 10 years ago. Now the drawing of a car changes every month. So every month, and the dream is that you will go to the garage and order your own car. I will. So this is how we at Sant'Anna School of Advanced Study with this problem, and it's the same. But we underline the fact that the economy is changing. For example, Uber-like structure, this kind of impact can have on manufacturing or logistics. And then, okay, vision, IoT, machine learning, but maybe we can do more. We will be able to do more in the next 10 years. And then the other important addition is circular economy, because I will come back on this, but a big problem that we have now is that it's a very good thing that all the previously underdeveloped world is becoming developed as the US, Europe, Japan, Russia. But this means that a lot of people will want car, and wash machines, and air conditioning. And this will put a pressure on the available resources on this planet, which is not bearable. So this planet is not enough for 7 billion people. So, and the other thing is the humanistic standpoint. Now, I promised some examples. And this is taken from a real project which is ongoing in the Vespa, you know, the scooter, the Vespa production plant in Pontedera. So you have some, and here you see how it actually, for example, in the production of scooter or cars, this is not a problem for workers because there are already so few workers that it is not economically useful to fire them, so to speak. Because what you now need is the creativity. So you need someone who knows the process and can suggest improvements. So now people are useful. If a person only does a very routinary work, it's not useful because a computer and a robot can do it much faster. So this is also individual strategy. But for example, this work is still done in factories. Even in this factory is very automated. But for example, when they do some precision working on the engine, they do it manually. And 8 hours doing this work with this grinder, it's heavy. You can use you can be helped by an exoskeleton. This is an application of exoskeleton, not for elders, but for young people doing a boring work. And again, here you have people doing these small drills into this part. This is, you know, this is a Vespa put in this way. You can have a person doing it, not doing it, programming it easily on a robot. The point is that this person is not an engineer or a programmer. He's a blue-collar worker. And again, here you have this, you have people, because surprisingly in factories, one of the big things that people do is to extract different objects from baskets. This can be done automatically. Another test is to test the brakes or the acceleration. This is now done by someone who sits on this treading mill on the Vespa and try if it is okay. This could be done by a simple arm. So these are, and then you have a lot of big things to dismantle and to waste. This is something that, again, can be done by some simple robot that works in a structured environment. So there, what we are able to do with vision will work. So, and this is, I was talking about the circular economy. So why the circular economy is relevant? For this reason, population going up and the exploitation of resources is growing even faster because luckily the economy at planet level is going well. So a lot of people want more things. And this means that this is an article that we may have a look, but there are a lot. Actually, we are running out of resources. So what's the solution to this? The solution to this is that my old car that I don't want anymore because it's out of fashion and has limited functionality with respect to new cars. Well, why I need, now what we do is that we mine other iron and other minerals and we build a new car from scratch. But while not disassembling this, since also the new car will use steel, less steel, and build the new car from the material of the old car. This is the idea of a circular economy, for car, for everything. And why it was not possible until now? Because now we know very well how to put together things. But all new cars are the same because they are according to the design. All old cars are different because they have get hold in different ways. And this means that you cannot have blind robots because now we assemble with blind robots. So we know how the car is made. I don't need to see the car. It's enough that I put welding points in a number of places. But if a car is old and I want to disassemble it, I need to see how the car is now. So without vision, thinking of circular, people have been talking about this model, no? So first I assemble new product, disassemble, I recycle the material, new product, better product, usually lighter, so using less resources. This has been a dream for decades, but like the lot of one customization, was a dream because it was economically unviable. But if I have mainly vision and I have a touch sensing in my robot, I can dismantle things. And the nice thing is that while vision is probably still not enough good for your house or for the wild, in a factory, if the algorithms suffer with blue, I simply avoid to have blue on the walls. So a factory is a structural environment. And I can structure it in such a way that my vision algorithms work. And you see, this is a creative, so you need to think. So what is exciting is that before working in a factory was extremely boring because it was following a well-known procedure for decades, and then you retire. Now, you need to see what you can do with these opportunities. And as told, is something that has to be done. So circular economy was not possible, now is possible. And this is actually this is an example of a B-manual robotics platform with vision and sensing on the tip and torque sensing here. This, I don't have a movie now, and but this is able to do things like taking a shopping bag and taking away the things from the shopping bag, or is able to take an assemble and to, and it's not, it's a kind of, someone won't like this, but this is applying force control, which is known, it's written in the books. Buying touch sensors that are cheap, and you need to connect to wire to your end of your robot. It needs a torque sensor. Okay, this costs some 6,000 euros or dollars, but you can buy two. This platform costs 150,000 euros. No? So with a limited additional cost, you have something that before was only able to weld in predefined places. Now is able to disassemble things and to sort things. And then, okay,
Can we make a short break to change the...
yes. So, okay, but I repeat it. So first, effective in cloud. So cheap things, but perfectly personalized. Not only, we can add to the stereo speaker a Wi-Fi card which allows me to talk with my smartphone to the stereo speaker. So, and this is the digitalization of the products because it's very concrete. So the effect of this Industry 4.0 is that can really change everything. So what you have around you and what how you produce it. So it's industrial age without the bad things of industrial age, because the bad things of industrial age are massification, everything, everybody's dressed the same way, doing the same things. No, this is the end of that. Because if you put together the web and this changing the production facility means that the world is changing. Is changing means that we need to change it. Another aspect that is less felt in Europe, but is very important in the rest of the planet, is that the massive urbanization that in Europe and the developed country happened in the 50s, in the 60s, in the 70s, or even the past century, is now happening in Africa, in China, in the Southeast. And what happened here was that a lot of terrible houses were built because the problem was giving a roof to a lot of people quickly without spending a fortune. If you think about, if you create a flexible prefabrication plant and you put robotics and AI in the construction site, you are again in the same situation. You can have nice design houses for the masses, because the point was that is this. So we can mass produce things of high quality. This is a novelty. And with a larger, and this is because you, I don't, but if you think about, you can translate what I was saying about manufacturing to this. What you can do is that you have a manufacturing plant, because prefabrication, this example, this is from the 70s, this is Robert Rogers, which is a very famous archistar. He was dreaming of building cheap houses of high quality. He was a great architect. And this is, but it was impossible, because you may have built hundreds of thousands of this kind of house. And then if you put them together in the suburb of St. Petersburg, it's awful. So what you can now do is that everybody can have a different apartment or house. And at the cost of the ugly buildings of 40 years ago. This is a change, but we don't feel so much, because we should first destroy our cities and then build another one. But where they are, they have all these people. Think to Nairobi or Lagos. A lot of people coming in the city, and they are in slums sometimes, or in very bad, small, crappy buildings. This can be avoided. In fact, in China, they are doing a lot about it. Now, so three things. The main thing is complete redesign of the objects that you can produce, including your house and your schools and your building. The second, but what about the sustainability of this for the planet? Well, we can recycle, because we basically is vision and sensing, and the connection of vision and sensing. I close by saying that, so everything is okay. Well, from a scientific point, we are not happy. Well, I'm not happy. And now I really go to the conclusion, because this approach, the so-called mechatronic approach, so to have a state machine implemented on an array of microprocessors, driving a complex mechanical structure moved by by electric motors, is good, but has limits, because this machine costs 2 million and requires 10 people to be operated, and it's very dumb. No? So the idea is that, but I really go fast here. So people are already, like me, are already thinking of the next stage, where we have self-organization of behavior, emergence of capability of recognition. But this is what I call the third wave. No? So I'm sorry, but this is also interesting, but maybe I will go deeper in next seminar, which will more dedicate to this thing. So for example, we don't know to what extent to have a real good robot that doesn't fall down this way, but sometimes also humans fall down this way. What of a principle of organization of a living system we need to copy. So this is not today but the point is that we may incorporate some aspect, for example, swarm intelligence or self-organization, characteristic typical of a living system could actually be exploited in robotics and also in the supply chain, also in these things. But this goes more. So this I will, there are a lot of problems now because this really I don't have time to go into the details. But again, because this is, I discussed this slide because it's very much in the spirit of what I wanted to tell you today, because of course, deciding if you have or not a steering wheel on your self-driving car is an engineering decision. But how you decide what to do. For example, we have two companies which are both active in self-driving cars, which have completely different philosophies. Because in this case, they don't even have a steering wheel. So this means that the car drives by itself. If it stops, you need to call someone. But you cannot move from there. The approach and the idea is that they are targeting, so they are trying, implementing new algorithms, a new system, and the target, when we are ready, we will give you the car. The approach by Tesla is different because they implement functionalities as they are available. So they test single functionalities. When they work, they implement on the software of the car. And this would be another, talking about the digitalization of product. A Tesla car is like a smartphone. They send you through the internet the new software, the new operating system and the new apps. So this is a big smartphone on wheels. And this is, they are front runners, but this is what is going to do. So if I have sensors here, I can have an app managing this table. So I will have a versioning of a table, even if the physics of a table doesn't change. So it's important to enter in this. But this is very different. It's very different. So who is right? I don't know. But for example, from just to, we always talk about insurance. You may have heard about insurance and legal issues. From a legal standpoint, which is better, because so it's clear. If you have an accident, the guilty is Google. Here, if I participate in the driving, could be me, could be good. So from the point of view of a lawyer, or keeping low the cost of a judicial system, this solution is better. Because it means that people cannot litigate, they cannot argue, because guilty is the manufacturer. By the way, there is, in this directive, people has been, there are strange things like when people will be person, we will have to behave properly with person. But there are serious things, and one of the serious things is that they are moving, so they wanted to make the manufacturer responsible. This is the main idea. Even in the case of Tesla, in Tesla would be Tesla to pay if they have an accident, when these new rules will be enforced. Because if you think in terms of a system, as a society, we don't want people to lose a lot of time in trials, in the discussing with judges about how much who need to pay for the accident. Because you know that one of the pictures was a deadly accident occurred to a Tesla. So It's only a matter of time before we have a self-driven bus killing 20 children. So just wait. Because you have accident with a standard system, one day you will have one of these. But the problem now is that we don't know exactly who should pay. Not, and this really, in the last minutes, the impact, something which worries a lot people is the potential impact on jobs. Because so a lot of things that before were done by machines were now can be done by. I have no time to go into the details of this analysis by Osborne and Frey 2014, but I can tell you how it was done. Basically, they classified jobs looking at about 3 dimensions. If I need social intelligence, if I need creativity, and if I need perception and manipulation. And then they decided that washing dishes doesn't require social intelligence. But planning an event requires a social intelligence. Or being a clerk doesn't require a lot of social intelligence. Being a fashion designer, not a lot of creativity, because if you are a court clerk, you apply the laws. If being a fashion designer or a biologist requires creativity, or an engineer, I would put engineers there, or a scientist. And the same, no? So how much capability you need in perception and manipulation? Nothing if you are in telemarketing. Very little if you are a professor. A lot if you are a surgeon. And so, on the basis of this you see, those are linear, very simple linear models. They came up with this, saying that about 40% of existing jobs could, in 10 years, be automated in the UK, so in an advanced economy. The only thing that I want to say is that you should be, all those lines should be justified, and we are not able now to justify those lines. So we actually, the truth is that we don't know. What I know is that, for example, now there are a lot of people risking their lives operating on tension line or in area where you have a lot of electromagnetic pollution or potential explosive storage of fuel. And this could be automated, and this would be saving lives. The other thing, and now I'm really, someone says that, it would be nice if robots and AIs do all the jobs, because everybody could, this is the position of the author of this book, so we can really have a real socialism. No? So nobody works, the robots work for us, and we are free to cultivate our artistic no? So it's bad. It's not clear. Unfortunately, it's probably not yet true. But if it was possible to make only the robots and the AIs work, we were like noblemen of the Middle Age. You know? So you do nothing, and you do. So it's not. Could be boring, but it's not. The reason why I'm not so worried is that if you look at what's happening by this issue, unfortunately, because I would be happy to spend my time on the beach, is that the population of this planet is growing very fastly. It's growing the worst, not in the right places, because we have infrastructures in universities, internet networks, logistic networks in a part of the planet where people is getting old and old. And we have a lot of new people coming, mainly in Africa, but in other areas where there is no infrastructure. There are limited, not many universities. So we have this situation that we are going to have this part, shrinking part of the planet, well equipped with a lot of manufacturing plants, logistic networks, communication networks, and this part where there will be a lot of people with limited resources. So what I expect that people in this part of the planet, we will have to work a lot to make the people in the other part of the planet able to survive. Also better in our own interest, because if they cannot survive there, they come in mass here, and then, so all the migration problem actually is a consequence of the population growth and the climate change. Apart from people wanting, so I'm here because I'm curious about Russia, right? A lot of one could be from Lagos and come to Italy because he's curious about Italy. This is what is it's less less nice is that you are pushed to leave Lagos because you have no hopes to live well in Lagos. That's not nice. The other big problem that we have is that this planet is actually, we don't know exactly what's happening, but we know that things are getting worse because the temperature is going up, extreme weather events, so not just hotter, but also colder, are more frequent. And this means costs, because, for example, in Alaska, in Chicago, they had this called wave a few weeks ago. This means a lot of cars are broken and a lot of buildings needs to be restored, refurbished. Those are costs. So if it happens once, it's okay. If it becomes an habit, it lower the living standards because you have to work for that. So since robots are things that allow to have more productivity, what I think is that that productivity won't be used, unfortunately, to reduce the working hour, but to be able, with less people, to do more, because doing more will be dramatically necessary. Because a pessimistic could say, looking at the trend of climate, would say, okay, go to the beach because we are done. No? But not necessary. This is the story of the aging of the population. So the fact that this is already a serious problem in many countries. The fact that there are a lot of people in need of attention. So people who need to care, and there are not people for caring of them. So if people cannot work in a factory because in the factory there is less need of workers, maybe they can move to the health system, the caregiving system. So it's not. So what I want to say is that it's a very good thing that we have the possibility to do much more with the same people, because we will have to do really much more, at least during a transition phase. So I'm now really finishing. So what we can see beyond this phase. I was talking about this deeply bio-inspired approach. What we, and while other things are already ongoing. For example, the browsing internet that we have today, no? So you go on the internet to browse or to buy something, could become a distributed computer, like for example in Ethereum. No? This is the attraction of equipment and service will cost less and less. So it's a typical expression to say that the cost of everything, the cost of production of everything is going to zero. The emergence of this bio-automation. So what we can expect is a system where you will have some mass production, for example, of chips or component, screw. But you want to produce a car in a mass manufacturing plant. The car will be built by someone close to you, and you can even discuss when they assemble your car if you want something different. You say, and the same for energy and for for energy supply, because you typically have logistic, manufacturing, and energy supply. You may think that this is science fiction, but from the standpoint of the concentration, you have server farms which are highly concentrated. So the search engines are based on huge index that running on a huge number of computers. The chips, something that the people never say about the Moore law is that not only it double the cost, not only you reduce the cost of the computing power every 2 years, but also the cost of the manufacturing plant of the chips double according to the law of Moore. So the chip industry is one of the most concentrated industry. So this is a new plant of Intel which costs 7 billions. So there's a space. I don't imagine that you build a new rocket in your garage. You need big companies to be active in space because you need many, many, many people. So you will have, and also even car logistic. So what we now, because now why we have cars? Because we want to go to point A to point B in the city individually. Tomorrow, this could be a service provided by this kind of object. So a small object, you call it, you sit there and go to the university. But this is probably a concentrated service because now the only company that can dream of doing that are Google, Uber, so there are a handful of companies. So you have, so this new scenario doesn't necessarily, but then you will need artists more than before. You will, the car, because I quoted the car, no? This is a 3D printed electric bike. And this is not something that I am seeing for tomorrow. You can buy it if you are close to the people building it. Drones, and then you still have people doing artistic craftsmen. So what you can expect is that it will become even more polarized than now. So a lot of very tiny individualized production, but also some super concentrated, and the same for energy, because of course you can put a roof, a solar panel on your roof, and this is depending maybe also on the latitude, but could be a wind turbine, a small wind turbine. Or but you also have huge offshore wind farms. And we are getting closer to fusion. So fusion means that the free plants give power to all Europe. And you see that we are very divided on this planet, but all the main countries of this planet are working on ITER, which is the demonstrator of nuclear fusion. So you see, you can also see US and Russian flags cheek to cheek. So, so everybody is, so in the future you may have a few huge, big fusion plants and many people with solar panels. I was talking, and now I think the bad thing it could have been surfaced by what I was saying, that it's good with super concentration. So the fact that a few economical actors manage everything. For now, maybe yes, because it's an improvement. No? So it's better, it's more effective buying a book on Amazon than waiting 3 months that they order it from your local library. But also means that Mr. Bezos and wife are concentrating also. It's a lot of money moving from the nice guy in the library, in the bookshop close to your house and goes to Seattle. It's good. I'm happy for that, with that, but I'm a bit sad for the bookshop person. So is there a way to have a digital, a web managing money without this huge concentration of economical and capital power in a few. Yes, maybe yes. We would need something like a peer-to-peer for money. And also here we are lucky because a peer-to-peer for money exists. It's the famous blockchain. So everybody has been talking, for example, last year about the blockchain because so there was a bubble, so everybody was thinking to make fast money with blockchain. But that's interesting. I have nothing against making fast money, if you can. But this is something that can last. So the blockchain is a way to distribute the trust. Because now, why I buy on Amazon? Because I know that Amazon.com exists. I can give them my credit card, and I know that they won't, I hope that they won't give everybody my credit card. So if there is Amazon and Alexander.com, well, now I know Alexander, but before I would have chosen Amazon, even if they asked for a lower price. The idea of distributing trust and data, which is what is most in the hundreds of different kind of blockchains, is what may destroy this. Because then, if there is if the community trusts Alexander, and Alexander asks just 1 ruble less than Amazon, I will buy from Alexander, even if I don't know him. And this is, so actually, we don't know in which form, but the systems like the blockchain can close the loop of the internet. Because so far the internet was proposed as a way to give to distribute the power, no? Like the solar panels. So we will produce our energy, build our bikes, and manage our data. What has happened is that we had an enormous concentration in a few actors for a matter of trust. Because I trust Apple, I trust Amazon, I don't trust you. I don't trust you because I don't know you. No, and again, I don't want to go. I want to finish now, no? Before being pushed out of the room. So it's interesting also from the societal impact, because we are actually disassembling, because this, so actually our society depends a lot on our material ways of living. And what is going to happen is that our concrete material of living can be extremely affected. So this means possibility of making money, possibility to give a new role to, for example, to see Italy and Russia have a lot in common because they were very strong during the industrial age. But now they are suffering with a competition, for example, for East Asia. This is an opportunity because if you have a refined culture, you can invent a nice product and nice services. And you can actually don't depend on exports to live because you put wind turbine, you have your fusion reactor. So it's an opportunity. So because the economy is the end point of having infrastructure, basically. And we can have much better infrastructure. So this age of discovery, and this is we are 2 slides from there. This age of discovery is a very nice book that I suggest you to read because it makes a parallel between the age of geographic discoveries from the European standpoint and now that was the period of the Renaissance, is now considered a great period of humankind, and it was. But that was a small elite collecting resources from a lot of people, and there were a lot of problems because the only fact that America exists from religion was a huge problem. So people was safely waiting to go to heaven after death because they were good people. And suddenly they discovered that a lot of people didn't believe what they believed. Was even behaving in very strange ways. And this was a tremendous problem. And also, Italy was, before discovering the discovery of America, was the rich part of the world. After the discovery of America, was first Spain, then the Netherlands, then the UK, were the rich countries, because Italy became, from being the center of the world, to be on the periphery of the world. This was a big change. What's happening now is that we are all periphery and all center. This is the nice thing of the internet. So you have a much more possibility to play. So I recommend to read this. So the last message is that, so don't, only without going into the new bioautomation concepts, what we have already, IoT, machine learning, some AI, mainly vision, able to recognize objects, it's enough to have a tremendous impact. What we need is to creatively understand what I can digitalize, how I can change a production process. So, and this is going to really distribute the power, because in the carbon age, which is now ending, having the oil and having the refinery was power. So who has the oil leads. In this new economy, the power is really your knowledge. So, and they are much, your knowledge, and the citizens are more independent from the power, so to speak. And this is a new thing that can have a nice and so that this is my personal dream. So I hope that this tremendous improvement from an economical standpoint, but really because now we are thinking about a crisis, economic crisis lasting from 2008, but actually we are in front of what could be one of the most prosperous ages in history. This is, so really a mass global, so not just Italy and a few parts of Europe, but all the world, and not just a small group of privileged people, but most people can enjoy really having a much more possibility to express themselves freely. And this thanks to this. And so that's all. Thank you. Almost okay.
We have a few minutes for the questions, if you have them, of course. Any questions? Okay, the one from my side. What do you think about the main dangers from the combining all the things together? I mean, the internet, the production cycle, industry, and all those things in the internet. Is any dangerous there or not?
Globally speaking, no. Socially speaking, I think that the big problem now is the knowledge and digital divide. So the fact of now, so in the past, having a good understanding of science, technology, also culture, economy, was something useful for people in top position in the society, but was not particularly useful if you had to do your job. Now it's different. Because you need to understand, because you need, for example, to plan your career, to decide. And the point is that everybody, before there were a few entrepreneurs and many executors. Now, in a certain sense, we are asked to be entrepreneurs. whatever job you do, if you are a professor, for example, you are an entrepreneur because you look for funding, you look for ideas about what to publish. It's the same mindset of a shopkeeper. So it's exactly the same. So, so the fact that some people knows. So in the past, still now was to have or have not. And this is important. But now, if you know and you have the right connection, you can have. But if you don't know and you don't have the right connection, you can't. So I think that one is the educational divide, and the other is the digital divide. So you need to have access to the network because so bandwidth is a kind of basic need. So it's and again having tools to be part of a web or not is a problem because not everybody is on the internet or so this is it seems far in time, but it's not so far because already, for example, it's clear that being in the Silicon Valley is a benefit with respect to be here. But this is going to change, assuming that you have sufficient bandwidth and that you know the same things that people know. So if ITMO gives you the knowledge that Stanford can give you, then, and you have the same bandwidth that they have in San Francisco, then you are on the same level. This was not true before. So before was, if you were MIT, why the MIT was such better than most other schools, or Oxford? Because they had a huge library. And if you were here and wanted to read a book, not a common book, you had to go to Oxford because they had 50,000 books in their library. But now I don't need to go to Oxford. I just subscribe to a digital library online. So this kind of advantage are not there anymore. But the real advantage now is to know the latest ideas and to have the capability to think critically and creatively. So knowledge and critical, so education, so of course we are a bit biased here, but it's like oil. So knowledge is the new oil.
Okay, thank
Yeah.
you. One more question. You talked about the advantages of customization and individualization of different products. Do you really think that this is a step forward? Because even now, if I want to buy a car, I have the option of maybe 20 or 30 manufacturers, and each of them has like 10 models. And even now, the decision to buy the perfect car for yourself is really hard. So if there are even more options for cars, for clothes, for everything, I will spend like my whole day making the choices.
It depends. It depends. I don't know. No, I see that the point is that you have the options, while tomorrow you may really decide your car. So it's not. I understand. It might seem not such a critical thing, but it is because people. The problem is that for example, it's clear, for example, in clothes. No? So last year it was fashionable green. This year is fashionable magenta, purple. Okay, so this means that all existing pink clothes pass from a value of 100 euros to 0 because nobody wants pink this year. So, and this is true also with cars. So if you can, because what I like, for example, of Tesla is very traditional because actually they have two models. They have the S model and the free model. But they have software. So basically they sell you a big smartphone. So, and you can do more things. So they was in the news. You read that they had added Pac-Man to the Tesla free console. Okay, But if you like, it's funny, right? No, I think that it is useful because you may need a different, because the extreme of what you say is that we have Trabant. Why you want another car? 4 wheels, moves, it takes you from A to B. No? Actually, we went in the opposite direction. So now everybody wants something new. You would like to change car every year. No, I understand what you said. The point is that it's not anymore choosing among options, but asking directly what you want.
I think it will be another one opportunity the sharing economy, because I think in the future nobody wants to own something, because you need to make a lot of things like insurance and all the stuff with the documents, and it's not so cool. But with the sharing economy you don't need it, and maybe in the future this sharing economy, but
In fact, I quoted it.
of the goods will be the best way to solve the problem.
Both.
Oh, maybe. Let's see. Any questions? No more? Okay.
Okay.
Thank you.